Hello friends, in today's class we are going to see construction of predictive parsing table. Hi everyone. The next thing that we are learning here is this construction of predictive parsing table. So we have already seen the model on which this top-down parser work, non-recursive predictive parser works. And every time there is a pair, non-terminal and terminal, we have already seen that M, capital A and small a, this type of pair. So it always consults this table, and that table is nothing but predictive parsing table. So now what we'll do here, we'll first learn this, and this is one of the important part for this top-down parsing. We'll learn this how to construct this table, and it is pretty simple. I'll explain you the algorithm, and then I will demonstrate with using this rules by using example. So your input is a grammar G, and output is the parsing table M. For each production A derive alpha of the grammar, do step 2 and 3. So we have to repeat this 2 and 3 step. For each terminal A in first of alpha. So what we need to do first thing we have to compute this for every production, and then we have to compute what? First of alpha. Okay, first of alpha. Where is alpha? Alpha is on the right hand side of this production, alpha. Add A derive alpha to M, capital A and small a. So you compute first, and if a small a terminal symbol is in first of alpha, then you put that entry into the table M, capital A and small a. So you put this thing on eighth, capital eighth row and small eighth column. Okay. Third says that if epsilon is in first of alpha, then add A derive alpha to M, A comma B for each terminal B in the follow of A. So in case the second condition that may occur is if a non-terminal derive alpha, and if I compute the first of alpha and I got here, suppose epsilon is present here, then I have to put this entry. Okay, I have to put this entry on each terminal B, which is where follow of capital A, follow of capital A. So this I have to be careful that I have to calculate the follow of capital A. So we'll repeat this process and make each undefined entry of M be error. So if there is a blank entry in the table, if there is a blank space, blank cell basically, then that cell will be a nothing but an error. Okay, so that is how this construction of predictive parsing table. The next thing I will do is I'll take an example and I'll fill that table for you. And now we'll discuss this example, and that is nothing but the construction of predictive parsing table. So I have taken a grammar which for which we have already computed this first and follow set, and we'll fill this table, and this is basically the non-recursive predictive parsing table. I already told you it's a two-dimensional table, and this side is the rows are nothing but your non-terminal, and input symbols are in the column, and these are nothing but your terminals. Remember that there will be a dollar, and dollar will be as an input symbol as an end marker. Okay, so dollar is my end marker. So now what we'll do here is we'll go production by production and we'll apply the rule. So E derive T dash, E derive T dash. So what was the rule here? If A derive alpha, then this will go to where it will go? First of alpha. So we'll compute here first of what? T and E dash together common. Do not because if there is a epsilon, then I have to go to E dash. So first of T is first of F is opening bracket and ID. Okay, so first of this is coming as opening bracket and ID. And now what I'll put here this entry E derive T dash here in opening bracket and ID. So E derive T E dash I will put over here, and E derive T E dash I will put it over here. Next, your production is your plus T dash, and here the first symbol is very pretty visible that it is plus. So E dash derive, here I'll put entry here, E dash derive plus T E dash. Okay, the next one is E dash derive epsilon. I'll come to this E dash derive epsilon later. Epsilon, we have a different rule. T derive ft dash. The next production is your T derive ft dash. T derive ft dash, and we know that here it will go to the first of f t dash. Okay, and we first of f is opening bracket and id, so this entry will go to opening bracket and id. So T derive ft dash, T derive f t dash, opening id, and T derive f t dash. The next one is your T dash derive star, and the first symbol here is star, so T dash derive star. So we'll put the entry over here as T dash derive star ft dash. T dash derive epsilon, I'll come later over here. And now f derive opening bracket and this e, this one, and the first symbol is very much visible that it is the opening bracket. So we'll go to this place and we'll write here f derive opening bracket e closing bracket. The last one is f derive id. Okay, so this f derive id, and the first symbol is directly I can write here f derives id. So now we are left with e dash derive epsilon and e dash derive epsilon. E dash derive epsilon. So where it will go? So it will go to follow of e dash. I have done this computation in earlier videos, and here if you say follow of e dash is follow of e dash is follow of e, so hence it is dollar because of the start symbol, and follow of e is also closing bracket, hence I will put here a closing bracket. So e dash derive epsilon will go to dollar and the closing bracket. So e dash derive epsilon will come over here. E dash derive epsilon will come over here, dollar, and closing bracket, and e dash derive epsilon will be in this here. Follow T dash derive epsilon. The next entry is T dash derive epsilon. T dash derive epsilon. So where it will go? This will go to this follow of T dash. So follow of T dash is what? Look at here. Follow of T dash is follow of T, and follow of T is nothing but first of E dash. First of E dash is plus. I'm bit, if you're getting confused, then just refer previous lectures. And if I replace E dash with epsilon, then it will become E derive T, because E dash I can replace it by epsilon. So here it will become the last symbol rule, and follow of T will be also follow of E, which is nothing but dollar and closing bracket. So now there are three places. T dash derive epsilon will go to dollar, first of all plus. T dash derive epsilon will go here, plus T dash derive dollar will, T dash derive epsilon will be in the dollar column, and T dash derive epsilon will be in closing bracket column. So now we are done with this, and we have filled the entry, and every other entries that are blank here is your error entry. Okay, so I am just writing few entries over here, and that is nothing but your error. That means a parser will stop parsing if there is some reference that goes into this error entry, because it is not possible. Okay, because it is not possible. Let me complete this one. So let's have this error entries. Okay, So now this is the complete table, and like if I say that E and plus, so I just read the input and the first symbol encounter here is plus, then immediately we can say that I cannot derive any string that starts with plus with this E, and immediately I'll say error, and the moment error will come, we'll stop the parsing and announce that it is not possible to derive this plus and it is not syntactically correct. So that is the example of your predictive parsing table. This is the next example that I'm discussing over here for computation of predictive parsing table, and this grammar accept that this left recursion. So we have already calculated this first and follow, but that time the production was something like this: B derive, it was capital B and B or C, something that computation was there. Okay, so let's come down to this, because I'll say that what will be the problem with this, and it's a what type of the production it is. This one is, it's a left recursive grammar, and I told you previously that it is not possible for top-down parser to parse a grammar which is having a left recursion. So let's fill the table entry over here. So first is your sderive abdh, and here A is the first symbol, so definitely it will go to the A column, and I'll write here sderive A, B, D and H. I hope it is visible to you. Then B derive small c capital C, so that is also very easy to fill here. B derive small c capital C. So that is first of the first alphabet is C terminal. So I'll put here B derive small c and capital C. C derive BC is also okay. We don't have a C column. Okay, so how to fill that, manage that one? So let me put a column over here. Okay, so let me just write this column over here. Okay. Okay, so now we have a C over here, and let's fill the entry over here. So now this is this C derive BC, so that is very easy, that it will go to the B column, and C derive B here is C derives small b capital C. C derive epsilon, C derive epsilon, so follow C derive epsilon, so that C derive epsilon will go to follow symbol. C derive epsilon will go where it will go? Follow of capital C. What is follow of capital C? Follow of capital C is follow of capital B. Follow of B. Okay, follow of capital C is follow of capital B, and follow of B is first of D, which is G, F and epsilon. Okay, so now we are having a G and F. I am just doing this computation very fast because I already explained you, and because G and D can derive epsilon, E epsilon and F epsilon, and hence H also, so G, F and H. So C derive epsilon will go to the three columns, that is your G, F and H. Okay, so now we have another mistake. This is let's call it as G, let's call it as F. Okay, so now it will be G column, F column and H column. So C derive epsilon will go to G column, G and F, G, F, H, and so C derive epsilon will be here. C derive epsilon will be in G column, and in H column C derive epsilon. So we are done with this. D derive EF. So the D derive EF, so that will go to the first of EF. Okay, D derive EF we want to parse, and this will go to first of EF. And these are the symbol here. Here is G, F and epsilon. So G and F, we are very clear that in G and F, first G and F column, like here for D, this one, so G and F definitely I'll going to fill this. D derive EF, and here also D derive EF. But when it comes to epsilon, first of D contain epsilon, and in that case also I have to also consider the entry follow of D. Okay, why? Because this epsilon symbol is here. So follow of D is what? Follow of D is only one symbol, that is H, and follow of D is H, and hence this H also will have the same entry, that is D derive EF. This is one of the important part, and you must consider it, that we should write here this one as D derive EF. Now we have a E derive G. So E derive G, so definitely E derive G will go to directly to this E derive G column. E derives G, and F derive F will go to this column. F derive F definitely will go to this column. Next is E derive epsilon. So E derive epsilon will go where? It will go. What does the rule say? That E derive epsilon will go follow of capital E. Follow of capital E is first of F. First of F is F, and if I replace this epsilon, then follow of D, which is H. So F column and H column. Okay, F column and H column, I have to write E derive epsilon. Okay, so E derive epsilon will go to F column, E derive epsilon. Why? Because first of F is F, and E derive epsilon will also go into this H column, because follow of D, E derive H epsilon. Finally, follow of F derive epsilon. So F derive epsilon will go to follow of F. Follow of F is follow of D, and there's only one symbol over here is H. So F derive epsilon will go to the H column. F derive epsilon. Okay, so this is my parsing table. With this, I would like to comment or just say one statement, and remember the statement, that if the parsing table is consist of single entry, and rest of them is what? Rest of them is your error. So I'm not putting this entry, error over here, but these all are your error entries are there. Okay, so I just make one statement over here, that if predictive parsing table consists of single entry, sometime it will called as unique single entry at each cell, then grammar is in LL1. Okay, this is the statement, and this is one of the important statement, that if the parsing table consists of single entry, unique entry, single entry, or we call it as unique entry at each cell, then the grammar is in LL1. So this is the example of a grammar which is LL1. So this grammar I can conclude here with this construction of this parsing table, that this grammar is your LL1 grammar. Okay, so later we'll see more example of LL1, but this is the two-part construction of the parsing table. We have done it, and whether commenting whether the grammar is LL1, so that also we can find out by using this table. Okay, so that's all for this session. Thank you.